For our Mechatronics project, we decided to create the Teleoperated Vehicle with robotic arm. The idea was to design and build a rover that had the ability to grab objects and was operated with a remote control. Recent efforts by companies like L3Harris and Boston Dynamics inspired us to make this project, as they have invested heavily in teleoperated multi-mission vehicles to do things such as disarm explosives and transfer items in conditions too unsafe for humans. The goals of our project were to implement a grasping mechanism for holding and manipulating objects, create a 1 degree of freedom motor-driven arm, and to create a pressure-sensitive grasping mechanism, which would be the focus of our PID control loop. Here is a general system block diagram of our gripper mechanism. On the right, you can see the mechanical setup of our linear actuator, end effector, and pressure pad location. The gripper is controlled by a simple motorized linear actuator that will be run with PWM from our microcontroller's feedback loop. Here is the final design of our device. On the front is the previously mentioned gripper and pressure pads. Behind that is the linear actuator that controls the gripper. At the base is the circuitry including H-bridges, 15-volt battery, MSP432, and of course the motor to rotate the arm. Finally, the two motors located on the back wheels that act as the drivetrain.
I'll set up like an obstacle for it, unless you want to. This is actually so satisfying to watch it move. Yeah, I know.
Here is a video of our vehicle in action, driving for the first time. While the wheels do slip from time to time, it seems to be doing a good job otherwise. Finally, here is a video of the arm rotating, both up and down. Here's a video of the gripper working for the first time, holding a roll of duct tape. Even when shaking the object, the gripper seems to be able to hold onto the object fairly consistently. Here's a video of our gripper grabbing and lifting a box. For our perturbations that we put on the system, we first started by simply putting our hands in between the gripper and pressing the pressure pads. This allowed us to dial in our K values. We then put an object in the gripper and pulled down on it quickly to simulate slipping to see if the claw could adjust its grasp to the varying cross-section of the object in a reasonable time frame.